By the way, it was controlled we controlled also a coil of stepper motor, both green and white and red circuit, power circuit, for value of resistance and inductivity. As can be seen, resistance is a half of ohm and inductivity is about 0.1 millihenry. These values are acceptable for such stepper. And let's consider how does this block works. Operator in a cab push a joystick to a forward gear, corresponding signal by means of CAN bus. CAN bus is a second and fifth pin in a main connector. Corresponding signal from by CAN bus is delivered to controller. Controller creates corresponding potentials at these switches, and corresponding wires of red and green power circuits are activated, and motor is shaft of motor rolls clockwise or counterclockwise. If the operator pull a joystick in a rear gear, we have the same by CAN bus corresponding signals is delivered to processor, and another map of potential is activated on these switchers, these four switchers, and current of another direction roll the shaft counterclockwise, corresponding reference line we have here, and we will consider this line later. So how does a command from a joystick is delivered to the shaft is clear, but because of extremely importance of this position from a position of shaft from viewpoint of safety, it must be another channel of control of position of shaft, that the shaft moves exactly to put on front gear or rear gear, and independent analog channel to control this is realized in this electronic control board by means of third pin of main connector. This pin is a reference pin. Main control unit delivers a reference voltage to this pin. Third pin is here, and the chart of this analog control channel presented on this chart. This is a pin 3 of main connector, and we have a voltage from reference voltage, for example 5 volts from the main control unit. Current can flow by this way through the resistor with higher resistance to ground, or if this transistor is open, current flows through circuit with lower resistance through this transistor to ground. In first case, value of current is about 10 milliampere. In second case, 4 times higher. It's about 14 milliamperes. The work of this transistor controlled by 26 pin of controller. If we have zero potential here, logic 0, this transistor is closed, and we have 10 milliamperes here in this circuit. And if a magnetic sensor is located under this cover, and this sensors control the position of this shaft of stepper motor, sensor delivers information that this reference vertical red marking line crossed by this shaft rotation is this direction, clockwise or counterclockwise. Information of from rotation sensors goes to by these wires to electronic board and then to controller, and depending of information from magnetic rotation sensors, controller put on logic 0 or logic 1 at the incoming pin of this transistor, control pin of this transistor. So by this way, main control unit understands the position of this shaft and can confirm that commands from joystick are performed correctly and in a right way. So it's really shaft moves clockwise or counterclockwise, and indicator of this is a current inside of this circuit. Let's check that it's okay from this viewpoint. As I already told, this is a third pin of main connector, and the logic 0, logic 1 can be checked at this point. Let's connect multimeter to this circuit to control a value of current. The reference voltage is supplied by this power bank. He plays a role of main control unit. Now, when shaft is slightly counterclockwise from this reference red line, we have a zero in this point from controller, and we have 10. We have 10 milliamperes, and now I roll shaft counterclockwise, or by another way I put on front gear. Now we have 40 milliamperes. Now I push shaft backward counterclockwise, and we have activated a circuit with higher resistance, 10 milliampere. This is rear gear. Now I am pushing to front gear, 40. So it looks like sensors and this analog channel to control position of shaft works quite right, and we will continue with control of the same control of position of shaft with can sniffing.